Greetings to you. In this session, which is the fourth session of robotics, we want to go over the topic of designing a robot's body so that you can see what tools you should use to design a robot's body and how you can build this body. Physically, you can see that the robot body is one of the important parts in robotics, which allows you to physically take a robot apart and use that robot. Now, it doesn't matter if your robot looks like a car, that is, it moves on wheels, or it has an arm that is positioned on a table, or anything else. However, you do need a physical body to use a robot. Fortunately, there are many software programs that allow you to easily simulate parts using those robots. The software you learned in the previous session was mostly about you having the robot come to the software and actually implement your mental idea. You could figure out how to build your robot, for example, with what parts and how many parts it would have, but the software couldn't give you an output that would convert that body into physics, that is, into a physical body. On this account, you should start learning software that allows you to do traditional design with them. In fact, if I want to put it simply, create template. One of the best software that has a lot of uses, and I recommend you learn it, is SolidWorks, which allows you to do this. You can easily fit any type of part or body, even a rotating device, anything you need into the soft RAIN. We do not provide software training in this robotics training course because it is a completely separate area and requires a completely different training, and the software is very advanced and complex. And now that we're trying to promote this nader, that's when we need to know the body's terrarium. After you have designed the body in software like SolidWorks, now it is time to make that design your own. Turn it into an actual physical structure, or actually take that mold in your hand. For example, a robot arm, if you made a terrarium, hold that arm in your hand, touch it so you can attach a motor to it. Actually attach electronic components to it so that the arm moves for you. Unfortunately, if you want to physically transform the mold design you made, you have to go through plastic injection molding. If it's plastic, which is mostly plastic. If it's dandruff, you have to see a dermatologist, and it's very painful and very expensive. But fortunately, a tool has been created, and now there is a printer called a 3D printer that, in addition to drastically reducing your costs, reduces them to the point where you can actually convert your favorite design into a physical model at home. In addition, because you can easily do this yourself and don't need to go out and do a lot of digging, all you need to do is buy a printer once. And then the only cost to you is the money for the materials that you actually have to pay for the printer so that it can print using those materials, which are usually called filament. What can it do? It can do proof printing for you, and those materials are not very expensive. You buy a kilo of filament once, for example, and it depends on the size of your filament and the density or quality of the filament. You can easily print dozens of physical molds and structures with a printer and easily use them in robotics. And there's no need for you to go straight to plastic injection molding and stuff like that requires a lot of decoration and takes up your time. Using a basket printer, which is one of the important tools in robotics, will really make the work more enjoyable for you. And the printer itself is actually a type of robot that can easily do the printer's work for you. So I am talking about the Saboti printer in the narration. You have also seen the videos of the Saboti printer working here. So I suggest that you proceed with this method. So far, there are two main parts. One is the software part and the physical design of the robot and the software, which I suggest is SolidWorks, and converting that template into a physical structure. You can easily use a 3D printer. Now, if for any reason, although I suggest you get a 3D printer yourself, you aren't able to get a 3D printer or use it, you can still. If you make the same mold in SolidWorks, Terraria, and then take it to a place that offers 3D printing services, it will still cost much less than, for example, things like plastic injection molding. This means that if you go to a place that provides printing services, for example, to print that template for you, the cost will be even lower. The good thing is that you won't have to worry about maintaining and buying a printer, as a printer doesn't really cause much of a headache. But if you want, for example, you can't do it for whatever reason, you can have this done for you. Make the template yourself on the computer using SolidWorks and have it printed for you. And you can still make your own robot body this way. When it comes to you, you start designing the template yourself, and then you want the printer, and you want to print. You can do this very easily at home, and I want to show you an example here. When you export from a software called SolidWorks, for example, you usually have to export it in STL format, which is the format that the printer software is going to receive this file. Because 3D printers have their own software that, in addition to preparing this file for printing, also translates it into the language of the 3D printer. You can even see a preview of your template, even resize it, and perform many different operations on the template before printing, such as choosing the quality of your template to print. Quality means that the mold is very strong and compact, or that it is not, for example, of low quality and there is no problem, or even that it is so flimsy that you can do all of this using a printer before the shop. Do it, for example. I'm opening a file here. This is a plastic screw and nut that you're making from a printer, which makes it very easy for us to even screw in nuts and bolts. This means that this net printer is made of carbide and can easily screw in robotic parts. For example, let me unscrew this bolt and I'll open the steel file. You get a template like this that you can see is completely three-dimensional, meaning you can view it from any angle. Then this is the template you see here. So it's actually the size of the printer and the size of the printer. When you buy a 3D printer, the 3D printer also comes with software as mentioned, the software that I'm using, which is one of the software related to the printer. And each printer has its own software, and there are different software for it. But the software is much easier to use, and its settings are more manageable, and it has a lot of settings and options. And it is also a smart software that I use for my own printer. You can easily design the screw here, and when you design it, it comes up like this. You can prepare it and ask it to print. An example like this, if you use this software, here's a section I'll show you that is related to the settings. So, for example, I'm going to choose my material type. See, there's both ABS material, meaning you can make this screw or any other mold using ABS, meaning you can easily do the job using ABS filament. And also PILA, which is a type of bioplastic that has the most cardboard because it is very easy to print and without a drill head. And when printing, and since the printer does this with heat, PLA does not produce toxic gas, while ABS produces toxic gas. Now this is a separate discussion. I have to explain this to you in full. Here, for example, I can choose the density of the mold as much as I go towards 100%. The more dense the surface, the higher the quality of the surface. In return, the printer uses more materials. The finer the shape of the paint, the better the quality of the paint, and the printer uses less materials. Now, depending on that surface, you can consider the appropriate quality, which is an experimental issue, and you really have to experiment. We have nothing to do with the other setting. Here, we just want to talk about the bodybuilding tools for robotics, so you can do the work. When you have made the settings and are ready to print, for example, on the preview, I click once, prepare for the printer. I click on the button that we see here, which is called prepare. Prepare for the next step. We select the materials with which to print. For example, it is pile, and I click OK. And you see that here I am taken to another page where I can save this file. I can output in two ways. If I select this USB and connect my pen to the laptop while it is drawing, I can also see the pen here. If not, I want to not involve this computer at all and put it in a RAM and connect it directly to the printer itself, and the printer will print without the need for a computer. I have to choose the output on the memory card, which is this. In any case, I can use any of them according to my needs, and before printing, I also get some general information, such as how long it will take to print this. For example, it is written here that because I chose the high quality, it will take about 4.5 hours. It will take a minute to print this, of course. According to our experience, this software has errors in this part. But for example, if it goes to 4 hours, it may take less. For example, 2 or 3 hours, it may take a little more. Then, how much will be the weight of this mold? That is, how many grams will it weigh? As you can see, it is 12 grams, meaning it will weigh 12 grams. And how much material will it use? You can see it all here. Then, before we print, we can see an output in the form of a movie of our printing process, which I'll show you here. I'll click on this step, and you see that the printer will start printing like this. See, it continues exactly like this. If I want to print the form, if I do more or if I counter, I can increase and decrease the speed. Show me how the left will be, for example. Here you can see my meat at the maximum speed. So the printing is finished here, and you can take your cut, and you can do the work easily. Now, to get you better acquainted, I'll show you one of these templates. I'll pick one at random, you see. For example, there's a structure that's been designed using SolidWorks software, and if I need it, I'll print it. For example, how does a printer print this? Let's see a preview of it again. I'll play it here. See, of course, I'll reduce the size so that we can see it a little better. The printer comes exactly as you see it. It prints that mold. I'll slowly rotate it so that you can see exactly how the printer works. You can see that because we're constantly moving and making different parts, we move exactly like that. And you can see that it's preparing the mold. For example, it says here that it takes 2 hours, 5 minutes, and 2 minutes to make this one part for us. You might think that's a lot of time, but it's really not a lot of time because it makes very high quality parts and costs us very little. If you use the same mold, if you let plastic injection molding do it for you, you have to pay a mold fee, and then it takes a while. So this is our hardware tool that can be used as a printer to print parts. And now you know what software and tools to use that don't cost much, but instead have your hands open for all kinds of designs that I definitely recommend you use. So in the next session, we want to go back to the discussion of electronics and get into electronic work in robotics, so that we can start designing simple robot circuits so that we can slowly learn to see how we should build those robots that do something, because before we even discuss the body, you can then build the robot at all. Next, you will build the main circuit of the robot so that you can consider the body for it. You will start working on all of this from the next session, and you will gradually become more fluent in this matter until the next session. God forbid,